when we're doing integration, and particularly with this sort of question that has fractions, it takes a bit of practice to recognise the different approaches. Depends how the fraction is written as to what you have to do with it. A single term on the denominator can be separated to two separate fractions, like I've done with that little box on the right hand side there. So this time we're going to separate x over 4 over x squared and 1 over x squared, and then by just using indices we can simplify that one down. So now it's ready to integrate, increase the power, divide by the power, add our constant c. Integration is the reverse of differentiation. So for our trig function, we look at the right hand side of that formula sheet with the table, and we come back to what was differentiated. Integrating cos takes us back to sine, and we have to divide by the 2. If you differentiate, you multiply by 2. Integrating, we do the opposite, we divide by 2. For the bracket, increase the bracket, the power by 1, divide by the power, and divide by the 4 from the bracket 4x minus 1. If you differentiated that bracket, you times by the 4, you integrate, you divide by 4. Dealing with differential equations, remember differentiation and integration are opposites. So to get from d2y dx squared, I have to integrate twice to get back up to y equals. Each time you integrate, you'll get a constant, and yet actually different constants, so you label them c1 and c2. So integrating negative 4x, increase power, divide by power, negative 4x squared over 2 plus c1. Now they've told us up in the start that dy dx equals 12 when x equals 2. So this is what enables me to work out our value for c1. Substituting dy dx equals 12 and x equals 2, I get c1 equals 20, and then dy dx equals negative 2x squared plus 20. From dy dx to get back to y, I need to integrate one more time. Integrating dy dx becomes y equals negative 2x cubed over 3 plus 20x plus c2. And here I can make use of the next bit of information. I've got y equals 20 when x equals 1. So using y equals 20 and x equals 1 allows me to finish off by working out c2 and writing the final answer. Question D is very similar to question E. We tend to set it out slightly differently though. We've got different variables here. We've got v and t, and our first step is to separate anything with a v on one side and a t on the other. So I end up with dv equals e to the 0.1 dt. Integrating each side gives the 10e to the 0.1. The 10 has come from dividing by 0.1, and when we divide by 0.1, it's equivalent to multiplying by 10. Now, those three steps are exactly the same as what happened on the green section from question C. We didn't separate the variables that time because it was just dy dx and in terms of x. But any other time, it's best to separate the variables properly and do it like I've approached question D. So here we've got our equation for v, having worked out constant c. And I'm going to come back to the question now, and I need to find the time when the volume equals 200. It's important that you can work back and forth between power statements and log statements. So I've got 11 equals e to the 0.1 t, log of 11 equals 0.1 t. Taken logs of each side and solved t equals 23.98. And question C, our excellence question. If you're having difficulty following this, just ask at some stage during class. Very common to get a question on either trapezium rule or Simpson's rule. Copy down the formula from the formula sheet, and h is the distance between two values of x. So h in this case is 0.25. When we're numbering our values for y, our first term is always y0, and then up to, well, in this case, y8. y0 and yn are just the first and last values for y, 4 and 1.7, and then it's 2 times all the other values. Question B, when you integrate e to the x, the same as when you differentiate, the power or the expression for e stays the same. Integrating e to the 1x becomes still e to the 1x divided by 1, so e to the x. I substitute 2k into it, e to the 2k minus e to the k. Question C, what we're trying to find is the area for two separate shapes. The area of the blue triangle and the black area underneath the parabola. We need to work out some coordinates. We need to know where the line crosses the parabola, which I've labelled point A, and where the parabola crosses the x-axis. So there's my working in the page there, and I've got A is 1, 3 and B is 2, 0. The triangle is simply half base times height, and the black area is the integral from 1 to 2 underneath the parabola 4 minus x squared. This expression in the question, 1 minus 1 over 5 t plus 2, that's the h dt, the rate the height is changing, and we have to integrate that to find the equation for h. So I'm integrating 1 minus 1 over 5 t plus 2, and for now our time starts at 0, and so up to n seconds is our limits, 0 to n. Substituting n in place of the letter t gives us our equation here for the height. Question E, another differential equation. Where it says is proportional to, then what we do is we write that. That's where the k has come from in this expression. The h dt is proportional to the cubed root, or equal to k times the cubed root. K is called a proportionality constant. As you work through this, if you have any questions, just come back and see me at class time. Question 3a, from our tables, if we integrated secant x tan x, we'd come back to secant x. So secant 3x tan 3x goes to secant 3x divided by 3. Remember, if you differentiate secant 3x, you'd multiply by 3. If you integrate, you divide by 3. Question B, when you're just given the equation and told to find an area, it's always best practice to draw it on your calculator first and to see if there's part of it's above the x-axis, parts below the x-axis. In this case, what I'm trying to find, that blue shape is all above the x-axis. So I'm going to do my integration, integrating sine 2x, negative a half cos 2x. I'm then going to go to my calculator and get it to work out the value for me. Integrating the fraction 2x over x squared plus 1 is very different to what you did in question 1a, where you had a single term on the denominator, and we could separate it into separate fractions. In question C, we need to do it by substitution, and so we let the denominator equal x squared plus 1, du dx equals 2x. Now when you look at the question carefully, I've got 2x dx in the question, and that's going to become what I use for du. So u is the 2x dx over u, x squared plus 1. Integrating that, log u. Now, you can't put the limits in here. You've got to go back to the original question. So I had u was x squared plus 1. I now get log x squared plus 1. Putting m in place of the x, I end up with m squared plus 1, and then the 0 squared plus 1 just leaves log 1. Because log 1 just equals 0, I now finish off with log m squared plus 1. So in the question, I've got an integral equals log 26, which means log m squared plus 1 equals log 26. Solving that, I end up with m equals 5. Now it's only positive 5 because our limits for integration always go from smallest to highest. So it must be going from 0 to 5 and not 0 to negative 0.5. So only m equals 5. Rates of change are popular questions. So I've got dv dt. I'm going to first separate the and integrate. So I'm coming down to 640 square root 1 plus 20t plus c. Now to work out my value of c, it's this part of the question. So she blows it up to a volume of 840 and then attaches a pump. So its volume before she attached the pump is 840. The volume at time 0 is 840. That's how we work out our value of c. And once we have our value of c, we can then work out the value of the volume when time equals 6. And question E, one more differential equation to solve for excellence. Again, any questions on this one, ask in class.